Thank you, Ms. Nambani. Good afternoon, colleagues, and welcome to the grade 11 technical science question paper. We are going to kick off with question number 1, which is the multiple choice questions. If there are any inputs there, now is the time for us to rectify or look into any questions on question number 1.
Good day, colleagues. Thank you, Dr. Nambani. Thank you, Mavia. It's just clarity on question 1.6 as to how we got to the answer. And then also question 1.7. I think I personally need to go back and teach it correctly because I don't remember teaching it 1.7. So any colleague who is able to explain 1.7 and 1.6, thank you.
All right. Thank you, Tati Nambani. Question number 2, 2.1. A technical science learner needs to move from point D to C, which is 2.5 kilometers apart. Point D is located 210 degrees to point C. So I was put on hold. Hello? All right. Give the direction the learner will walk from point D to C in terms of compass direction. Then on the memorandum, it's saying that the learner can state either in words 30 west of south, or they can give it as S30 degrees, missing there, W. Are there any additional inputs to that? All right. Then the next one, they had to draw the vector diagram. All right, Mia. Draw a vector diagram using the bearing method to represent the position of D in terms of C, and use the scale of 10 millimeters representing 1 Newton. As you can see there on the memo, it is the Cartesian plane. I think, Mania, the only addition is there where it is 90 degrees, it should be 210 starting from the 0. So from the north all the way around to give it 210 there. Then it will be 1 mark award for labeled the vector and 1 mark awarded for vector in the correct quadrant. All right, so please scroll upwards. The next question, the table below represents the time and distance of a construction manager during inspection at the construction site. The table is giving there the time 5, 10, 1520 and the distance of 30, 60, 90, and 120 meters. 2.2.1, draw a graph on the graph paper provided at the end of the question paper and plot the movement of the construction manager. Then learners were expected to just draw it in their answer books. Teachers must note that the graph that is displayed here is now corrected to the time in hours. Then they are going to get 1 mark for the correct heading, which is distance versus time. 1 mark for the correct scale and labeling on the X and the Y axis. 1 mark for the best fit line. And 1 mark that the graph starts from the origin for both the X and the Y axis. And then the last mark is awarded to 3 consecutive points correctly plotted and give them a total of 5 marks. 2.2.2, they then have to calculate the gradient of the same graph. So they'll be using the formula given here, which is M is equal to change in Y over change in X. They accept the matching coordinates there, and then they should get the correct gradient M to equal 6. Then 2.2.3, physical quantities represented here. It will be speed, since while distance and time is given, regardless of the unit. 2.2.4, determine the equation of the graph. They had to substitute using y is equal to mx plus c, the answer from 2.2.2. So it will be positive marking from 2.2.2, which they will then use here to substitute and get y is equal to 6x. In 2.2.5, what is the relationship between the time and distance values? They are directly proportional, and that will give us a grand total of 19.
Thank you. I just want to ask on 2.2, I haven't marked all learners, but in case 2.2.2, 2.2.2, in case I haven't marked all the learners, but in case I come across a learner that converted the time to hours, to seconds, because it's given in hours, then calculated the gradient, can we award? Thank you.
Good afternoon, colleagues. So I would like to know there by 2.1.2. Yes, sir. So if you take the 0 on the way to the magnitude, it's 210, but now there where it says 90 degrees, shouldn't it be 30?
It must be
Yes.
30, yes, ma'am.
Like to know, sir, if the learner maybe put the 60 degrees on the other side, but the magnitude is still in the same quadrant, is also another option to mark it. Okay. Thank you, sir.
All right, thank you, sir. Question 3, study the diagram of a spacecraft launch below and answer the questions that follow. Assume that the spacecraft was on a flat horizontal launch pad before takeoff. Then they asked us to define normal force, which is defined as the force exerted by a surface at right angles to an object in contact with it, for 2 marks. 3.2, calculate the normal force exerted on the spacecraft if it has a mass of 82,000 kilograms. There we are going to relate normal force is equal to gravitational force, which is equal to mass times gravity. And then that should give them the normal force to be equal to 803,600 Newton. What 3.3? What forces do the following diagrams label refer to? FA is referring to applied force. 3.3.2, FF is referring to frictional force. 3.3, name the two additional vertical forces acting on the spacecraft that are not shown in the diagram. So that will be normal force and gravitational force, which also needs a tick added there. Then 3.3, what is the role of the thrust force FA during launch? So the expected answer is something similar to the applied force pushes the spacecraft upwards. That will be 1 mark, helping it to overcome the gravitational force and lift off from the launch pad. That will be the 2nd mark. And that will give us a grand total of 11. Please adjust them near 11. Meneer, can we underline the word upward, not the whole pushes the spacecraft, just the word upward. 3.5, the word upward, yes, meneer, alone. Yes, meneer, for the 1st mark. Yes, but the question is already asking about the role of FA. So it's not necessary to repeat it. Yes, meneer. Okay, yes, meneer.
Thank you, Ntate Nambana. How do you mark learners who wrote W is equals to M times G instead of Fn is equals to W, which is equals to M times G? Thank you.
Thank you, sir. Question 4, a force board is used to investigate 3 forces that are in equilibrium. Forces F1, F2, and F3 are acting on a knot at a point A. The angle between F2 and the horizontal is 30 degrees, and the angle between F1 and the vertical is 50 degrees. F1 has a magnitude of 8 Newton, F2 has a magnitude of 7.5 Newton. The diagram is given. 4.1, state parallelogram law in words. Then the definition is the parallelogram law of forces states that if 2 forces acting at a point can be represented by the adjacent side of a parallelogram, both in magnitude and direction, the diagonal from the point gives the resultant of the 2 forces. 4.2, use a scale of 1 centimeter to represent 1 Newton and do the following. Draw point A in your answer book. Construct forces F1 and F2 in magnitude and direction with the tails of the vectors at point A. Complete the parallelogram with F1 and F2 as two sides of the parallelogram and determine the resultant of F1 and F2. Supply suitable labels for all the forces in your construction and indicate the magnitude of the two angles in your construction. So for this question here, they are representing those F1 and F2 and the FG downwards, and the resultant as indicated upwards. At the bottom, it's written that the resultant should be approximately 12.5 centimeter. So it will range between 12.5 and 14.5 centimeter. 1 mark for the resultant, 1 mark for the length, 8 centimeter, 1 mark for the length, 7.5 centimeter, 1 mark for the FG, 2 marks for the accurate F resultant, 12.5 centimeter, and also the 12.5 newtons written there. I don't know, Meneer, here if I can say something because it also said indicate the magnitudes of the angles in the construction, but now in the picture, it's not there. Okay, then 4.3, I'll continue then the colleagues will give inputs here. 4.3, write down the magnitude of F3, so that will be 12.5 newtons. Then 4.4, what is the purpose of F3? They can be awarded 1 mark for saying that F3 is the equilibrium. Then 4.5, describe the relationship between the resultant and F3. The resultant of F1 and F2 and F3 are equal in magnitudes but opposite in direction. So I think we can put 1 mark at equal in magnitude and opposite, and the other mark at opposite in direction. And that will give us a grand total of 14. Any inputs here, please, colleagues?
Thank you, Dr. Nyambane. I just want to confirm also with the colleagues. I constructed the parallelogram, then I got 9 centimeters, and one of my learners that I marked got 8.8 centimeters. So I just want a confirmation of the resultant force, because from the drawing the adjacent side of the 8 centimeters, not adjacent to 8, also the, yes, thank you, Dr. Nyambane. So confirmation of the resultant force. And then also on the same question, Mevia mentioned the angles. So I wanted to ask, since well we must award a mark for indicating the angles, can we please remove the 1 mark from FRS? Oh, my battery is running low. Can we please remove the 1? We already have a mark at the construction for saying FRS, it's 1 mark. Then again, when you go underneath, it says FRS for saying 12 centimeters, it's now 2 marks. Then again, for saying 12.5 Newton is another mark. So in total for resultant force, there's 4 marks. Can you please remove the 1 mark, then award it for showing the angles? Yes, thank you, Dr. Nyambane. Just
Yes,
confirmation how much is the resultant from other colleagues and their learners And then I want to ask, meaning if my learner did not write f-res is equals to 12 centimeter, they already set f-res, then equal sign by the construction. I will give the learner 2 marks already from the construction, then the 1 mark for converting. Yeah, the 1 mark there by the 12.5 centimeter, that has 2 marks. Because we already have 1 mark for saying f-res on the construction. Yes, and then can we also have an option of instead of 8 centimeter, they can also write 8 newtons and 7.5 newtons, not necessarily in centimeters. No, I'm saying on the F1 and F2 that they number. Yes, just an option. Yes, 2 options that please. That number. Yo. That number. That number, when we mark them, it's 7.5 centimeter. It's also 8 centimeter because they used the scale. But when they label, because they know it's a force diagram, they label F1 as 7.5 newtons and F2 as 8 newtons. The labels for the forces. We don't award.
Yeah, oh, so okay.
So I also want to say something about 4.2. The the learner had to construct it in centimeters, but they must say the label with the symbol F1 equals to 8 centimeters. So, because now they can put 8 centimeters. F1 equals to 8 centimeter. Yes, sir. And then F2 must be, because you might find learners that will just construct it, but they won't label it which one, and then they can draw it the other way around. Sometimes you get learners like that. So I think it will also be fair enough to know that 8 newtons, which is F1, must be constructed at 8 centimeters. Yes, sir. You can't use the ruler for 8 newtons, but I mean, it will just indicate that the learner was talking about F1, which is most now 8 newtons, but it's equal to 8 centimeters, which show that the learner used the scale correctly. The other thing is also M with Matlaba, F res is 8.8 newtons. It doesn't work out to 12.5 newtons. 8.8 in that range, sir. 8.8 newtons, which is 8.8 centimeters. They don't conclude to 12.5 centimeters, sir. Yeah. Yes, or 8.9. I'm not sure. But what I've mostly seen, the learners constructed it to 8, something.
So I think 1 mark should be allocated to the method. For learners completing the parallelogram, there should be a mark. For the tail-to-tail method, there should be a mark awarded to that construction, those construction lines. Completing the parallelogram should actually have 1 mark. I think the 8.8 centimeter from the resultant is unnecessary. As long as they've stated it in Newton, it's fine. Which they've also constructed. You can put it to that corner there, Mania, to the top there. Yes, Mania. Yes.
Yes, leader. I agree with Meshaba there, my leader. Yes, we gave them the scale to convert to centimeters. But when they label, they usually label Newton.
Mm.
Yes, I agree with Mesha. We should award, if the learners right, 8 Newton and 7.5 Newton. No, I agree with you, but for now, let's benefit them. That's my take.
Dr. Nambane, thank you. Good afternoon. Thank you. Dr. Nambane, I humble request, if we are using 7.5 centimeters, that one was just a conversion to scale. But then when we are now changing the SI unit, it will be now, actually we have drawn the vector. So that is the vector, that is the magnitude of the vector. 7.5 newtons, we keep it the same. For the scale, when I'm using the ruler, if I want to measure if the sides are correct, I'll be using the ruler. If the learner is converted correctly to the scale, with my ruler, I'm supposed to get 7.5. But with the magnitude of the vector still remains the same, that will be 7.5 newtons and 8 newtons. Yes, as much as they've indicated, when they've indicated the scale, already that one will give me go ahead on checking if the vectors are correct. Yes, sir.
Thank you, sir. Question 5. A lawnmower is pushed along a lawn from right to left. A force of 300 Newton is applied to the handle of the lawnmower at an angle of 40 degrees to the horizontal, as shown in the diagram below. 5.1. Is the force applied 300 Newton a vector or a scalar? It is a vector. 5.2. Explain the answer that you gave in 5.1. They can either say a force is a vector quantity because it has both magnitude and direction, or they can speak in the negative and say because a scalar only has magnitude. Then 5.3, calculate the following. 5.3.1, the horizontal component, which is written in the memo as FH, F cos theta, which is 300 cos 40, and giving an answer of 226.81 Newton. 5.3.2, the vertical component, which is written as FV, F sine theta, which will equal to 300 sine 40, and giving an answer of 192.84 Newton. 5.4, what happens to the magnitude of the horizontal component if the angle increases? So then they have to answer there that the horizontal component will decrease. 5.5, what happens to the magnitude of the vertical component if the angle increases? And the answer is there that the vertical component will also increase. 5.6 is a statement before the question. As a lawnmower is pulled along the lawn with 300 Newton from left to right by a man, it became too heavy. A friend helped him and decided to exert a force of 60 Newton on the same object in the same direction. 5.6, determine the magnitude of the resultant force by using the head-to-tail method with a scale of 10 millimeter represents Newton, and draw the vector diagram for 4 marks. And in this diagram here, it will be 150 millimeters to the right, which will, as per the previous question, will be also 300 Newton. And then 30 millimeter also to the right, which will also be 60 Newton. And then the resultant, which will be 360, on their ruler, they will use 180 millimeter. And that gives us 4 marks, giving us a total to the question of 15 marks. Any inputs on this specific question?
Thank you. Apologies, I was kicked out when we were deliberating on 4.2. But right now I want to ask about 5.3.1 and 5.3.2. I see that there is a mark for the formulas for components. Do we keep it as a mark for a formula because it's not on the formula sheet? Or is that a number? Yes, thank you. Just that one of rest. Can we please increase the range of the number? I'm not sure. 4.2, remember, I was kicked out. I couldn't suggest. I do apologize. Okay, I did construct it. Before that, we had a range of from 12.5 to 14.5. It was a 2 difference. The real difference ya 2 ntate number ranging ya answer ya pele, but now arena yona. I was suggesting, since when we had a difference of 2 for the range, can we keep it at that difference in that?
10.8.
Yes, that number, please. Okay, data number. Thank you.
Leader, 5.6. I get you what you are saying, but we can use a ruler as markers to check, even if the learner wrote in Newton. But the ruler is for us to check whether you use the scale. In terms of the scale, then it limits us to say we must measure 150 there and 30 there. So if anything, if the learner measures anything greater than 150, then we penalize. That's my input. I don't. That's my input. I don't know. I don't know, sir.
Thank you, sir. Question 6. A car is towing a camper along a flat road. The total mass of the camper is 900 kilograms. While towing, the car exerts a horizontal pulling force of 270 newtons on the camper. The surface of the road is rough. The friction acts between the wheels and the surface. The diagram is given, direction of motion to the right. 6.1. Define the term friction, which is the frictional force that a surface exerts on an object when the object is moving across the surface. 2 marks. 6.2. Draw a fully labeled free body diagram of all the forces acting on the camper. So there's 1 mark allocated for the normal force. They can use Fn or normal force. Then there is 1 mark given for the weight, which can be WFG weight, FW or gravitational force. 1 mark for Fk, which can be F friction kinetic frictional force. Then the other mark is for T tension, which can be T tension or Ft. 6.3. Calculate the coefficient of frictional force between the camper's wheels and the road if the frictional force is 2,381 Newton. So they will use the formula Fk is equal to mu k times normal force. They will substitute the given 2,381 as well as the Fn. We also award the mark if they have calculated it outside of the formula, and then the kinetic frictional coefficient will be 0.27. 6.4. The camper becomes detached from the car. It continues to roll for a while and then it slows down and stops. 6.4.1. As the camper's velocity decreases, what will happen to the kinetic frictional force experienced by the wheels? Right? Only increase, decrease, or remains the same. So it will remain the same. 6.4.2. Explain the answer given. And then here, the Frictional force experience is dependent on the normal force of the object and the nature of the surface. The change in velocity will have no effect on the frictional force experienced here. So I was thinking that these this sentence here, the two sentences, I think there should be two options. Either the learner says the change in the velocity will have no effect for 2 marks, or they write about the frictional force being dependent on the normal force for 2 marks. And that gives a grand total of 12 for question number 6. Any inputs? Over to you, Mr. Nambani.
Thank you. Yes, I would like to agree with Mevia to make them 2 options. Can we please just go to the question again, Tata Nambani? The answer. The frictional force experience is dependent on the normal force of the object and the nature of the surface. Okay. I just want to ask colleagues if there's any other options of the words that are underlined there that can be options of answering the questions. Because when it's underlined, learners must answer it as it is. So, colleagues, any other ways to answer this question besides the given one? Yes, I do understand, but I just wanted to ask that if we make it 2 options, we can't part mark the 2 options. For example, the learner says frictional force depends on the normal force, 1 mark. Then maybe they continue to say that when I guess they're using statement 6.4. Yes. So maybe they say when the roll slows down and stops, it will not have an effect on the frictional force. Like, okay.
Meneer, oh,
My leader, I will always advocate for part marking for the benefit of these souls that we are teaching.
meneer, it can still be part marking within the options because the learners are relating variables to each other. For example, the change in velocity will have no effect on what. Then the second mark can still be for the frictional force experience. The same in the first part. The frictional force is dependent on what? On the normal force. So we're still relating two variables together. So therefore, it can still be part marking within those options. Part marking. Okay. Okay.
Good afternoon, colleagues. I agree with 6.4.2 being part marking. At least then the learner can get one if they don't have all the, yeah.
Good afternoon, colleagues. Kenana, the part marking is fine. Yeah.
It's question number 7. A wheelbarrow with mass of 45 kilograms is at rest on a rough horizontal surface. The coefficient of the static friction between the wheel and the surface is 0.9. A person is about to apply a force to move the wheelbarrow forward, but it has not yet started moving. 7.1, define the term static frictional force. The frictional force that a surface exerts on an object when the object is stationary on the surface. 7.2, calculate the maximum static friction force that can act on the wheelbarrow before it begins to move. So here they are using the formula F max is E equal to mu S times normal force. Then they are substituting the coefficient given and calculating the normal force and then getting the final answer as 396.9 Newton for 3 marks. 7.3, the worker begins pushing the wheelbarrow, but it does not move. He pushes harder until it suddenly stops moving and then finds it easier to keep it in motion. 7.3.1, explain using your knowledge of friction why it was harder to start moving the wheelbarrow than to keep it moving. So here it is written, when the wheelbarrow is at rest, static friction acts between the wheel and the surface, the maximum static frictional force is greater than the kinetic frictional force. Thus, a larger force is needed to overcome static friction to start motion. But once the wheelbarrow is moving, only a smaller kinetic frictional force opposes the motion, so it is easier to keep it moving. 7.4, what is the direction of the static frictional force acting on the wheelbarrow before it starts moving? It is in opposite direction to the applied force, or they can write to the right. And that is giving us a grand total of 259. Bringing us to the end of the question paper, a grand total of 100. I think there's some, yes, meneer, I was also static frictional force that is first. Yes, Mary can accept it even though it's different from the grade 12 one. Okay. Yes, so but can we add another one, the grade 12 one for limiting friction, static limiting frictional force? Because that one is also simple. It's that one of the force acts between two surfaces when the object is stationary. Okay. All right, Mina.
Leader, depends what he has there. If he has, I think if he has FS instead of F max, then we can accept.
Thank you, Tate Nambani. Can you please also just put for definition at 6.1 that we accept force that opposes the motion of an object when the object is like same definition just for moving object. I'm not sure. Let me see.
That opposes the motion of a moving object. Okay.
Yes,
Yes,
Tate
Meneer.
Nambani.
Remove 1A,
Yes.
meneer,
And then
of A more.
And then when it comes to the standard of the paper, a humble request to the examiners, can you please assist us when it comes to content training? The paper was very interesting. I've come across 2 questions that I might teach differently. They were asked in a different question. Therefore, I realized that we really need that content training, especially for grade 11. Also, when it comes to definitions of frictional force, we have different definitions there. If you can just have the definition that we use for grade 11 when it comes to static friction, kinetic friction, and frictional force. Because when you go to the textbook, different definition. That other document that you said it's outdated and that then different definition. So please, that content training. But it was a beautiful paper. Thank you, examiners.
Yes, meneer, maybe as a recommendation, we should focus on the definitions in the CAPS document for grade 11.